We're recording. It just has a little button up on top. There we go. Okay, so we're going to talk about instantaneous rate of change today. So the big deal with calc, or maybe I should say the difference between pre-calc and calc. Pre-calc as an idea for lots of things was you would find out averages of a lot of things. And calc, like the study of calc is the study of rate of change. And if you're trying to figure out how fast things are changing, it's actually helpful to know how they're changing at an instant, rather than how fast they're changing between two pieces of information. So you guys are very used to doing average rate of change, which this is using velocity as an example, just to kind of get you used to it. Position, velocity, and acceleration are going to be a big part of calc. And that's because calc and physics, so I'm going to guess a lot of you are in physics this year. Okay, calc and physics are pretty actually entwined quite a bit. Now you guys are in an algebra-based physics class, because I believe the AP physics is also algebra-based. When you go to college, you very well might be in a calculus-based physics class, which honestly feels entirely different. Like they don't even feel the same. Most of the things we do in calc are methods to figure things out in physics. Because calc is about trying to learn how to study the rates of change. And so when you're talking about things changing, position, velocity, acceleration just matches up really easy. So there's a lot of questions on that throughout the year. Now this kind of already says it in there. Do you guys remember how to find the average velocity? The average rate of change?
Science.
Ouch. I mean, it's not wrong, but it's not right. So, you guys probably in your head, when you think of velocity, a lot of you, since you're driving, probably think of miles per hour. Like, is that correct? I don't know. I mean, that's usually what I have done. So if you're trying to figure out velocity, if you think of it as miles per, because per is the word for divide, so miles per hour, that would be an easy way for you to help remember how to do velocity. Change in distance, change in time. So I think physics is, well, maybe not. You guys are starting physics today, right? Because you probably did the cooperative activities last week. They'll often show that little triangle, delta. Oh, that's probably from chemistry too, right?
Isn't there a velocity triangle where it has like the D in one corner, the T in one corner, the D in another corner? Or is that for?
You probably think of the distance equals rate times time.
Okay.
And then it probably has a DRT.
Okay.
Because to find one, you need the other two.
Yeah.
I don't know the triangle you're talking about, but I'm guessing
It's
that's
where you cover
it.
it up and you like multiply one side to get the corner. I don't know if you know.
That's probably the formula I'm talking about. I've never done it, but that's kind of makes sense. Should we have somebody be an example?
Yeah, I'll be an example.
Excellent, come on up, come on. We have a human example going on here. You ready?
Yeah.
Okay, we need a timer.
I got it.
Excellent. You ready?
Yeah.
Not you.
No. Just a stopwatch?
Yeah.
Ready?
Okay, so stand right here.
Do I start the stopwatch?
Well, once he starts moving, we start the stopwatch. Now, I need you to kind of take off slow. And by the end, we're going faster.
Accelerate?
Yeah. Whenever you're ready, go. He'll start timing and stop at the wall. Just stop before the wall.
5.32.
Okay, good. You were excellent. Excellent volunteer. So 5.32 seconds. Let's just totally guess how long this is. I suppose we could count squares. Should we just say 20 feet, because I really have no idea? Okay, 20 feet. (20 feet in 5.32 seconds. You got all the calculators. I'm not gonna pretend to do that in my head. It's gonna be smaller than 4.
3.7.
You're just guessing too, though.
Yeah.
We try not to guess.
3.4.
3.76. Now, estimating is a really good skill, but we try not to guess for actual answers. So feet per second. Okay, so that was his average velocity. Now, we call it average though, right? Because when he took off, he was going slow. And by the time he was done, he was going faster. So his instantaneous velocity was different along the way. So like, I would guess when he was right here, his velocity was probably like 1 foot per second. By the time he got to the end, I'm gonna guess it was probably 5, 6 feet per second, because the average would be roughly the middle. So the difference between pre-calc and calc is in calc, we want to try to figure out the instant velocity at different places. Now, what's the difficulty with doing that? Like, why can't we really figure out instant velocity? Like, how did we figure out average? Like, the bottom, right?
Yeah. Well, we timed it. Oh, we can't time it. We can't get a precise
So
time.
what would be the time for instant velocity?
0.
0.
You can't divide by 0.
Right. So the difficulty comes in that the numbers don't mesh. So down here underneath, instantaneous velocity is kind of difficult because you can't write it as a ratio. So ratio means divide, like fraction. You guys remember back from rational, near rational, remember we did the Kahoot? We did. That was sort of my like, pretend to do math, even though we couldn't teach. You can't write it as a ratio because you'd be divided by 0. Is that what you guys were trying to ask? You guys absolutely can ask out loud too, like, don't feel like you need to fill these out, and if you miss something, you
So
gotta.
instant velocity was like at a certain random point where I was walking.
So like when you were, technically at the very beginning, your instant velocity was 0.
Yeah.
And then you started speeding up, but you were going very slow at first. So your instant velocity was probably like 1 foot per second. And this is probably like 2 foot per second, 3 foot per second. Obviously, I'm not changing speed, but like this was probably like 5, 6 feet per second. Because slow to fast, the average is gonna be like in the middle. So we have to figure out a way how to find the instant velocity. And I believe that's kind of down below. I'm assuming most of you read ahead at the same time. What would be a good way to guess the instant velocity, or to estimate the answer?
You take it at a time other than 0.
Yeah, it says right below. Doesn't it say right below it? I thought in bold.
The leaning power. Oh, average velocity over a very small time interval is very close to instantaneous velocity.
Yeah. Do I need to translate that though, probably?
Yes.
Okay, that's definitely the looks I'm getting. I need to translate that. Is this the part that's confusing?
No.
Oh, 100, I just ask away, like, So my job is gonna be to kind of help you guys understand this and learn this.
So
I can tell you a million things, but like unless you understand what is being said, it's worthless. So this sentence right here kind of actually means a bit, quite a bit. What's a small time interval?
Like 1 or 2 seconds.
Like 0.1 seconds? Like a tenth of a second?
Yeah.
Okay? So if we do the average velocity from 1 second to 1.1 seconds, the average velocity right here is gonna be really close to the instant velocity. The problem we had was that we did an average velocity really far apart. So that's why the average was kind of the middle. So if you do average velocity over an actual really small time interval, so like 0.1 seconds sounds small, but it actually isn't very small. So we want to go much smaller than that. Ideally, we want to make the time to be nothing. But then we run into the problem before that you can't figure that out. So this is leading us to something called limits, where limits is a method to find an answer where there shouldn't be one. And that's gonna be our unit 1, like as a big idea, like that's not details or anything. Limits are going to be a way for you to find an answer for something that might not be there. Okay, so let's do this example on the bottom. I thought it looked pretty good. The Leaning Tower of Pisa is actually completely meaningless in this, and so, I mean, like, it's in the problem, there's a nice picture, but that's worthless. You're just basically dropping something, and you're timing it. That's all we're doing. You'll notice that the time interval gets smaller each time. And so our idea is to watch what happens as the time interval becomes close to 0 and make a guess from that. Okay, should we talk about how to find this answer first, even though it's written in there for you? Yeah? Okay. Literally inches above it, how did we find average velocity?
change in distance by changing time.
Change in distance between change in time. We're told the time interval right here. So this very first answer, the bottom of the fraction is 0.71 minus 0.7.
0.01.
Huh?
It's just 0.01, right?
Oh, yeah. I thought you were talking about the number right in there. Yeah, the answer is 0.01. How do we get the distance numbers from the top? Oh, we're supposed to pretend we don't know that answer yet. You're just given that answer, but we wouldn't know it.
Would you use,
Well, what,
Use Galileo's formula.
the, Galileo? You have to have heard of Galileo, right?
Yes.
School system is failing. That's okay, I guarantee most of you wouldn't even know how to use a ruler correctly either. It's utterly shocking and painful to watch people use a ruler. Honestly, metric rulers are great because most people just get that. The imperial English units doesn't go well. So this is the formula saying how far something falls if you just drop it. So it's the distance. I don't know why they use S. They traditionally use S of t for distance and position. I didn't choose it. So what we're gonna do is we're gonna plug 0.71 in place of 16t squared. That's gonna tell us how far it falls in 0.71 seconds. And we're gonna plug in 0.7 into that formula, and that'll tell us how far it falls in 0.7 seconds. And we're going to subtract them, and our answer is gonna be 22.56. Can anybody see the downside to making this table?
Takes a while.
Yeah, real slow. So it's real slow if you don't know how to use your calculator very well. Your calculator has tons of functions built into it to do this all super fast. So I assume this is where I should pause and show you how to use the calculator. Okay, the function that we're using for all of this is 16t squared, right? So we don't want to plug a whole bunch of numbers into 16t squared by hand, because that's the slow part. Where's my calculator? Oh, that came up weird. First thing, I'm gonna go to y equals. I suppose I should get rid of those. Don't be scared, don't be scared. Most of you probably always used y equals for a graph. I'm gonna guess that's what you've always used it for. The reason that they have graph as a separate button is because the graph of a function is just one thing. Your calculator automatically figures out tons of things for every equation you put in. So y equals is where you're going to put equations into the calculator to figure things out for those equations. If you want a graph, then that's why the graph is a separate button. Because most of the questions I get when people first start using the graphic calculators is, why do you have to hit the graph button separate? You know, I get it. I already figured out the equation, 16t squared?
Yes.
And obviously, we're not gonna use a t, we're just gonna use an x, because that's kind of how it's set up. So if you put a t in, it's not gonna work right. I 100% can start this over if you guys want me to. Some of you look flustered with the calculator. I don't mind starting this over. Hit y equals in the upper left-hand corner to get to this base, the location to put in equations. And then when you get to the x, this button right next to alpha, this button right here, automatically will do an x or whatever format you have the calculator in. So we have an x. And then squared, you can use the caret to put in squared, or there's a squared button. And then hit enter, and then your calculator automatically has info stored for that function. Now, above graph, it says table. Now, if I hit, because table's in blue, and whatever color your calculator is, I'm gonna hit the blue button because I wanna use the blue feature. Now, the problem here is it gives me a table for 16x squared, but it gives me like a table with just normal numbers, like it automatically generated, which is helpful, but not for the numbers we want. So we need to tell the calculator which numbers to use. I can't read it at all, but I think above window it says TBL set.
Yes.
Okay, good. So that's how to set up the table set. Right now, my table started at -2 and went by ones. The independent variable is the numbers on the left-hand column that were plugged in place of x. Right now, it's on automatic by this. What I want to do is I want to put independent on ask so that I can tell it what numbers to calculate. And now if I go back to the table, it'll be blank, because I didn't tell it what numbers to calculate. So I want to do 7 and 7.01. So 7, 7.1?
0.7 and 0.7.
So I already screwed that up. All right, 0.7. So 0.7 and 0.71. Now here's downside is, if you move your cursor over a number, okay, this one ends there. If the decimals go on farther than 4 spots, it'll only show 4 spots, because that's all space it is. So sometimes you wanna put the cursor over it to see if it's different. So we have 8.0656 minus 7.84. Unfortunately, you're going to have to write those down by hand, because there's no way to like click on the number and copy paste. Like, it's, depending on which calculator you have. This one doesn't do copy paste very well.
Could you go back to the table set page?
I can. So the only one that should be different is independent should say ask. So hit enter when it says ask. The numbers up top don't matter.
But what does the ask thing mean though?
That means the calculator is going to ask what numbers you wanted to put into the equation. I mean, it's not literally asking, it's just gonna leave it blank for me to type numbers.
Wait, so when we're making this table right now, like what are we accomplishing? Like what does this do for us?
That I can show you in a second. Okay, so I've got these two numbers. And knowing me, there is 0 chance that I'm going to remember these numbers. So what we were trying to do, Luke, this was your question. What we were trying to do is to figure out what numbers to put in place of distance for that equation. Like that was our goal to start with. And we just calculated that when you put 0.71 in place of that equation, you get 8.0656 and 7.84. And when I subtract those two and divide by 0.01, I get 22.56. So that was the answer that was written in there for you already. What am I gonna do to calculate the next box? Same thing, but, so 0.7 is gonna be the same numbers. 0.705 is different.
Can you back up? Why do you move the decimal over my answer like this number over here? Right?
What, you two did half questions, I didn't hear you.
Okay, I got 0.2256. Is that just the top, what you have written in red?
Yes, when you divide by 0.01, you'll get 22.56. Yes, the top is gonna be the same numbers, but decimal in the wrong spot.
Okay, thank you.
Yep. So the 0.7 is gonna be the same for all of these, but the second number is just gonna get closer each time. So for my second one, I'm going to have minus 7.84 and minus 0.7. So I'm going to go back to the calculator, which for you guys is sitting right on your desk. Yes?
Why are you subtracting them in that order? Because it's written 0.7, comma, 0.705. So shouldn't you be subtracting them in that order?
You could, same answer.
Okay.
Yeah, so if you do both, if they're both in the opposite order, they'd both be negatives, cancel out.
Okay.
I just do it like slope, like y2 minus y1 over x.
Gotcha.
So I want to do 0.705 for the next number, and then that'll give me my info to put in for the second answer. 7.9524. Did anybody divide those out? I have zero idea what the answer is. Perfect. How are we on that second answer? Because I will happily help anybody figure out that if they are in trouble figuring out the second answer. Because my goal is, I would like you guys to do the last three.
So I don't think there's anything you can do about this, but it says the TI-84 has expired for our,
Really?
Yeah.
You only got it for 1 year?
I guess.
Lame.
There's a calculator for
Yeah, there's tons of them for, technically there's TI-84 emulators, unofficially.
Does like so when you're subtracting the numbers, does it matter if you're doing like the bigger number minus the smaller?
No.
Okay.
So as long as you keep the order the same,
Okay.
your answer will be the same. You can do second minus first, top and bottom, or first minus second, top and bottom, and it'll get the same answer. I just, out of habit, I always do second minus first, because the slope formula is like y2 minus y1. And you guys will see it in a second, but we're doing slope. That's what instantaneous and average velocity is slopes. Okay, I would like you guys to take a couple minutes to fill out the rest of that table. What time did we get done? Oh, wow. Okay, so we did one example today. All right, that's all right. This is me learning the timing. Yeah. If you put the cursor over it, it'll show it. It's just, yeah, it does a weird thing because it can't fit the numbers. And it seems like each one of the calculators is slightly different, which is really odd. So, did anyone,
Oh, let's go.
that never happened in the other years. If, on somebody's calculator, when they were putting in these numbers with lots of zeros, the calculator showed it differently. If you put your cursor over it, it should show the full number. What page is that example on? Probably like 1. Oh, wow, okay.
Same equation as you. Isn't that just 22?
FYI, I do have the Unit 1 notes completely filled in, that I'm just going to keep up here. So if you guys ever miss something, like say you zone out for 5 minutes, and you totally miss something, which I'm gonna pretend nobody does that. I'm gonna keep all the answer keys up here for you guys if you ever need them.
Do we have the information we need to do the homework tonight?
I doubt it. Well, actually, no, I take that back. You might be able to. I wasn't gonna sign the homework yet, but you could try, you could certainly start some and try some. Okay, since we have 3 minutes left, I'll have to cut you short. 2 minutes left, sorry. So we can see that 0.1 seems like a very small amount, but actually isn't in terms of accuracy. Let's call in a random person. Let's go with, oh, no, because you're volunteering. I want somebody who doesn't want to volunteer. Let's go with the AC/DC shirt. I like AC/DC.
Oh, let's go. I got it.
What was your name again? Sophie. Okay. Sophie, if we had to guess or estimate what the instant velocity was at 7 seconds, 0.7 seconds, sorry, what would you guess? So, what are these numbers turning into essentially? Like if we look at the answers, we got 2256, 2248, 224016, 4008, 40016. What are they getting closer and closer turning into? Perfect. I would estimate the instant velocity would be 22.4. This is called a limit. A limit is when you find out the answer by looking at patterns for a number that doesn't actually exist. And, yeah, we'll do example 3 tomorrow, I guess.
Do you have any work in the packet for tomorrow?
No, if you want to try some tonight, go for it, just to see if you kind of get it. You can certainly start it, because the homework goes real slow. So if you guys want to start some of the homework, feel free. I'm not going to like assign any yet, but you're welcome to it.